Hello, welcome back to my video. And then today we're going to talk about the Pythagorean identity. So let's recall what is Pythagorean theorem, not identity, theorem. So in Pythagorean theorem, it states that in a right triangle, the two sides square is equal to the third side. If two sides is, I should use x, y, z. So the Pythagorean theorem would be the sum of two sides square is equal to the hypotenuse square. Z. You know what I mean? Everyone is familiar, everyone knows what is Pythagorean theorem is. So what about in a unit circle? What happens if it's in a unit circle? Now let's draw a unit circle first. Whenever it comes to a trigonometry question, is always easier if you can draw a picture. So this is a unit circle. That means on every given radius, this is going to equal to 1. Okay, let me use maybe a blue pen to draw that triangle in here. This is T. Okay, in this unit circle, I know that this is x and y, right? This point is x and y. So our cosine t equals to our x coordinate, and our sine t is equal to a y coordinate, right? We just learned that in the last section. All right, so now let's take a look. This is a right triangle on the unit circle. So what happened? So this part is the right triangle, and the hypotenuse is equal to 1. And we know that this side, the horizontal side, which is the opposite side of the angle T, is equals to y. The adjacent side of the angle T is equals to x. So by Pythagorean theorem, we have x squared plus y squared is equal to 1 squared, right? Because hypotenuse is equal to the radius, which is 1. And x is equal to what? By the definition of a cosine function on the unit circle, cosine is equal to x. So that means cosine t squared at y is equal to sine t squared equals to 1. 1 squared is equal to 1. So that's the definition. So here's some notation problem. So cosine t squared, you can also write it in this way. Cosine square and then t. That means the same thing. So let me write this. And this is called Pythagorean identity. So cosine squared t at sine squared t equals to 1. Okay, that's something new that we learned from something that we already know. See, math is all about building the foundation, and from the foundation we derivate to new things. So it's very important to build up a solid math foundation. All right, so we call something. You know that, again, you really knew this stuff. For a coordinate plan, we have 4 quadrants, right? This is called first quadrant, second quadrant, third quadrant, and fourth quadrant. So what's special about this 4 quadrant when it comes to coordinate? For any random points, x and y, our x is always going to be a positive number and y will be positive. Because in this quadrant, let's take a look. They covered what? X is the positive side because the negative side is on here, right? There's nothing negative in the first quadrant. X is always positive, so that's y. Okay, so similar to the second quadrant. So what happened to the second quadrant? Second quadrant is all the x coordinate is going to be negative because it's on the left side of the y-axis. So that's why all the x is going to be negative, and all the y still on the top of the horizontal axis. So y is going to be positive, For the third quadrant, x and y, they're both negative because they're on the left side and at the downside of the coordinate plane. For the fourth quadrant, x is going to be a positive, y is going to be negative. I believe that you already know this part. And so now why do we need to know that? Because that's related to when we calculate the cosine or sine function, we need to determine whether this is a positive or negative. Okay, now let me rewrite this in here, positive and positive. Okay, so if I'm giving you a question, if sine alpha is equal to 3/7 and the alpha is in second quadrant. This is my shorthand writing of quadrant. And I want you to find cosine alpha. How do we do that? Well, by the Pythagorean identity, we have sine alpha squared plus cosine alpha squared is equal to 1 because they're in a unit circle. Everything that we're doing now is assuming they're in a unit circle. And now we need to substitute the stuff in it. This is 1 squared is equal to 1, so you can just write it 1. But if you write 1 squared, that will remind yourself that this is coming from the Pythagorean theorem. But once you get really familiar with the Pythagorean identity, you can just write it as 1. Like, now, second step is sine alpha squared, which is 3/7 squared, at cosine alpha squared. We don't know this is equal to what, we can just replace it with an x squared. So we know that x means cosine alpha is equal to 1. Now let's solve it. 3/7 squared. When you're doing square, we can do it very quick. Here's a quick review. Like 3 squared. Square means you multiplied itself, right? Which is 3/7 times 3/7. So together it's equal to 949. So we should be able to do this very quick. It just square the top and also square the bottom. Square the numerator, square the denominator. All right. Now, this part is equal to 949. At x squared equals to 1. Let me use it back in this color. And now x squared is equal to 1 minus 9/49. Find the common denominator, which is 49. So 1, I can write it as 49/49. So x squared is equal to 14/49. But that's x squared, which is the cosine alpha squared, not cosine alpha. We're trying to find cosine alpha. So we're going to take square root on both sides. When you're taking square root on both sides, what happens is you're going to have a positive and negative answer, which is positive 14/49, and then square root. Now simplify it. We have either positive or negative 14. Square root of 14. Simplify it. We have 2 square root of 10/7. I want you to simplify the fraction. I will going to attach a video in this section and teaching you how to simplify the radical expression and simplify the fraction expressions. That's very important. All the answers should be simplified. If you didn't do it, I will take out 1 point. Okay, so now we have 2 answers, positive and negative. So how do we know which one is which? Now, here is the hint they tell you, or the restriction that they give you, is alpha is in the second quadrant. So where's the second quadrant? Now look back to this coordinate plane. Second quadrant is in here. That means x is a negative, y is a positive. Okay, if you don't remember that, you can just draw it by yourself and pick a random point and see the x coordinates and where's the y coordinates. So our cosine alpha is in the second quadrant. I should say since alpha is in the second quadrant, so cosine alpha should be equals to x, the x coordinate, which is the negative. So that means cosine alpha is equal to negative 2 times square root of 10 over 7. So we drop the positive solution. We just keep the negative one because alpha is in the second quadrant. Okay. Next exercise. If cosine gamma is equal to 24 over 25 and gamma is in a unit circle and find sine gamma. Also, gamma is in the fourth quadrant. Okay, since since gamma is in a unit circle, then we can apply the Pythagorean identity. We have cosine square gamma at sine square at sine gamma gamma square is equal to 1. And then the rest is just substitute the number into it. Cosine gamma is equal to 24 over 25. So don't forget to square them and add in this. Or we can just use x to represent it. Or you can keep it sine alpha. Either way works. Like the previous example, I replace it with an x. And this one I decided to keep it as a sine alpha, a sine gamma. Okay, then 24 over 25 using calculator is equal to 574 over 625 at sine gamma square is equal to 1. So subtract the fraction on both sides. I have 1 minus 574 over 625, which is 51 over 625 for a sine square. And then we take square root on both sides. Then I have sine gamma, not alpha, gamma is equal to positive or negative square root of 51 over 25 after you simplify the radical expression. Alright, so now we have two answers. Now we need to look back. Where is the gamma is? The gamma is in the fourth quadrant. So the fourth quadrant is the x-coordinate is positive, the y-coordinate is negative. Sine is the y-coordinate, right? So, because gamma is in fourth quadrant, then we have our sine gamma is equal to negative square root of 51 over 25. That's it. That would be the answer. Again, if you write your answer as negative square root of 51 over 625, you will be take out 1 point or half, depends on how many points on the questions. I want you to simplify it. All right. Next, let's do some summary and see what happened to the sines, cosine, and tangents in a coordinate plane. Are they positive or negative? So on a coordinate plane, we have 4 quadrants. The first quadrant, second quadrant, third quadrant, and the fourth quadrant. And then the first quadrant, we have x and y both positive. Second quadrant, we have x is a negative, y is positive. In the third quadrant, we have both x and y negative. Fourth quadrant, we have x is positive, y is negative. Once you draw the graph, you don't need to memorize it. You can just look at it, and then you know that if it's x is positive. If x is on the left, that means it's going to be negative. X is on the right is positive. Y on the top, above the horizontal axis, is going to be positive. If it's below the horizontal axis, it's going to be negative. Okay, and now the second thing that we need to remember is sine. Sine t is equal to y. Cosine t is equal to x. And tangent t is equal to y over x, right? Now, let's take a look. If it's in its first quadrant, if t is in its first quadrant, what happened to cosine t? Cosine t would be positive, sine t would be positive. So if they're both positive, we have a tangent. Tangent is equal to the positive number over a positive number. That will give you a positive number. Now, in the second quadrant, cosine is the x-coordinate. So that means cosine theta is equal to a negative number. Sine theta, it will be positive for all of the sine theta in the second quadrant. And the tangent theta is equal to a negative number, because if you have a positive number over a negative number, you will end up to have a negative number. Now, this one, cosine beta is equal to a negative number. Also, sine beta, which is the y-coordinate, if it's in the third quadrant, it will be a negative. Then tangent beta, you have a negative number over a negative number, then you will end up to have a positive number because they will cancel each other out. The last one, in the fourth quadrant, what Greek letter we can use? Maybe alpha. Cosine alpha is positive. Sine alpha would be a negative because this is y, cosine is x. Tangent, if you have a one positive, one negative, you will end up to have a negative number. So that's it. That's the summary. Let me know if you have other questions.